Hello and welcome back to part 2 of section 1-6 of geometry. Let's now complete the example problems together. Example 1, name and classify each polygon. We're going to name each polygon by its number of sides, then classify it as convex or concave and regular or irregular. So first up we have this guy has, let's keep track, 1, 2, 3, 4, 5, 6. 6 sides makes it a hexagon. Those sides are all marked as congruent, so that would make it equilateral, but the angles are not all congruent. So it's not equal angular. You must have both to be regular. So it is irregular. And notice the sides. If I extend this side here, it will run through the middle of the polygon, which makes it concave. Another way to define concavity is whether or not you can connect two vertices outside of the polygon. Okay, so notice that this connection here is now outside of the shape. Next up, we have 1, 2, 3, 4, 5, 6, 7, 8. Stop. That's an octagon. None of the sides can be extended inside the polygon, so it is convex. All sides are marked congruent. All angles are marked congruent. It is regular. Example 2, find perimeter and area. Find the perimeter or circumference and area of each figure. This first one is a rectangle. The area of a rectangle is length times width. So here it's going to be 3.2 times 2.1. And you know what I did not do is prepare an on-screen calculator. So you'll just have to believe me as I punch the buttons in here. I will try to get something prepared. There's just not that many great calculator apps for the iPad. 3.2 times 2.1. 6.72. We multiplied centimeters times centimeters, so that makes centimeters squared. Areas are always represented in square units. B. The circle, area of a circle, as you recall, is pi times radius squared. Our radius here is 3 inches, so this is, okay, technically it's approximately equal to, because pi is not perfectly 3.14, but that's good enough for us here, times 3 squared. So the area will be 3 squared is 9 times 3.14. That'll be 28.26. Some calculators do have a pi button. So if you use that, you would find you get 28.27433, etc. All right. Example number 3. Yolanda has 26 centimeters of cording to frame a photograph in her scrapbook. Which of these shapes would use most or all of the cording and enclose the largest area? A right triangle with each leg about 7 centimeters long. A circle with a radius. You know what? Let's start drawing these. Which shape would use the most cording to get the largest area? Okay, so we want to use, so if your perimeter here, let's start with the first one. A look like this. Would be a right triangle. Each leg about 7 centimeters long, and you'd have, let's see, 7 plus 7 is 14. I need to find the distance there. If you recall the distance formula, let's put this on subcoordinates. If you call this 0, 0, that makes this point 7, 0. And this point would be a 0, 7. So now this third side, distance is the square root of 7 minus 0 squared plus 7 minus 0 squared. Oh, look at that. It's 7 squared plus 7 squared. 7 squared is 49. So this is 49 plus 49. 98. The square root of 98 is 9.89. 9.9. 9.899. I'm going to round that to 9.9. Which means our total perimeter of the shape is 14 plus the 9.9, which is approximately 23.9, and we have 26 centimeters, so it's almost 24. We have about 2 left over. And what will be the area of this shape? Area of the triangle is 1/2 base times height, both of which are 7s here, so this is half of 49, 24.5, 24.5 centimeters squared. Okay, so that's one possible shape. Shrink that down and set it aside. How about the next one? Shape B is a circle with a radius of about 4 centimeters. The circumference of a circle is 2 pi r, so that is 2 times, it's a terrible 2. 3.14 times the radius here is 4. 2 times 4 is 8. 8 times 3.14 is 25.12. How about the area of the circle pi r squared, in this case 4 squared? 4 squared is 16 times 3.14, 50.24. Square centimeters. So I'm going to go ahead and put a box around that. Let's compare that to our triangle. So notice we're using a little bit, I forget that the laser doesn't work on just the one screen. We're using a little bit more of the cordage, and we're getting way more area. So the circle is winning by far right now. But we still have 2 more to check. So shape C, rectangle with length 8, width 4.5. There's a rectangle, length 8, width 4.5. The perimeter here will be 2 8s plus 2 of the 4.5s. 2 8s is 16. 2 of the 4.5s is 9. 16 plus 9 is 25 centimeters perimeter, just under the 26. And so now let's do area. Length times width, 8 times 4.5. Will be 36 centimeters squared. Okay, that puts it in between the triangle and the circle. Make that one a little bit smaller there. Scoot that in close. I don't know what that little line is. Finally, a square side lengths of 6. Part D is a square. It looks more square. Side length 6, so the perimeter is 4 times 6, 24 centimeters. Okay, we got 2 left over again. Not quite as efficient as the circle or rectangle. How about the area? Area is going to be 6 squared, which is 36 centimeters squared. So the same as the rectangle. Interestingly enough, we get the same area, but we used a little bit less of the perimeter. So the best shape here by far is the circle. Last one. Example number 4, perimeter and area on a coordinate plane. Find the perimeter and area of triangle PQR with the following vertices. I have also included the graph there. For the perimeter, we're going to need the length of all 3 sides. So that's this one we could count. The other 2 will need the distance formula. And then we'll also need to find the height of the triangle here to find its area. So let's call this side B, call this side A, and call this side C. The length of A will be the distance formula here, square root of x values -3 minus -1 all squared plus -1 minus 3 all squared. That is the square root of -3 minus -1 is -1 plus -3 plus 1 is -2. Squared is 4. -1 minus 3 is -4. Squared is 16. This is the square root of 20. Side B, we can just count the squares here. 1, 2, 3, 4, 5, 6, 7. And C is another distance formula. We have from point P again, -1 minus 4 squared plus 3 minus -1 squared there. -1 minus 4 is -5. Squared is 25. 3 minus -1 is 4. 4 squared is 16. 25 plus 16 is 41. So the perimeter equal to A plus B plus C is the square root of 20 plus 7 plus square root of 41. Let's go ahead and get a decimal approximation there. Square root of 20 is about 4.47. Square root of 41 is about 6.40. So plus 7 plus the 4.47 gets us a total of about 17.87 units, since they weren't specified. As for the area, remember side B was 7, height H we can count as 1, 2, 3, 4. So the area of this triangle, every triangle, 1/2 base times height is 1/2 7 times 4. Half of 4 is 2. 7 times 2 is 14. Area is always in square units, so 14 units squared. This concludes the example problems for section 1-6. So long, farewell, enjoy the rest of your day.